Hello, hello everyone. My name is Abhishek Arjun Supekar. I am present the topic virtual number of teeth and its impact on high helix angle helical gear design. The introduction part is helical gears are widely used to transmit power between parallel shafts where smooth coil operation and high loading carrying capacity are required. Unlike spur gears, the teeth of a helical gears are cut at an angle to the axis of the gear called the helix angle. It is denoted as psi. The second is functional requirements of helical gears. Transmit torque and rotary motion smoothly between parallel shafts with minor noise and vibration. The second is provide gradual progressive tool engagement to that load is picked up smoothly along the line of contact, avoiding the sudden impact seen in the spur gears. And the terminology according to this is terms are helix angle, normal module, transverse module, actual number, virtual format number of teeth, Lewis form factor, axial thrust, and that meaning is according to that. Classification of helical gears. First classification is single helical gears, double helical gears, parallel shaft helical gears, crossed helical gears, low helix angle gears, and high helix angle gears. Concept of virtual number of teeth. Here is the diagram of helical gear. Definition of helix angle. Impact of high helix angle on virtual number of teeth. At low helix angle, cos psi is close to 1, so TV is only slightly larger than T, and the helix gear behaves for strength purpose almost like an equivalent spur gear. Here is the chart for helix angle and the values of cos cube, TV and approximate Y. Means Lewis factor. Here is the graph of virtual number of teeth. Rises sharply with helix angles well above the actual tooth count. Several design conceptions follow direct from the behavior. The sixth point is industrial application of high helix angle helical gear. Automotive manuals and automatic transitions gear sets where high helix angles give smooth coil gear changes and high torque capacity in a compact envelope. Second is marine propulsion reduction gearboxes where herringbone high helix gear transmit very high power prop turbines to the propeller shaft while cancelling axial thrust. The seventh point is material selection for a helical gear. There are two material selections. First is alloy steel and second is medium carbon steel. Here is the designation, key mechanical properties and typical application. Point 8 is material selection criteria. In this, mechanical properties, manufacturing consideration and cost consideration is given. The last conclusion is the virtual number of teeth. TV is equal to T upon cos cube psi is the key parameters that links the actual geometry of helical gears to the spur gear based strength calculation methods traditionally used in gear design because TV varies with the cube of cos psi high helix angle. Designs express a disproportionately angle large increase in virtual tooth count which rises the Lewis form factors and effectively spreads the tooth root section for a given actual tooth number. Reference is from V.V. Bhandari, PhD, Relative Isotope for gear practice.